Hello, good day. My name is John Kairi Elisan Ambonsai, and in this video, I am going to discuss to you all about the Module 3 in Basic Calculus, which is the derivatives and the techniques of differentiation. Okay, since you have already learned how to evaluate a limit, you will be able to understand what derivative is. Well, derivative denoted as df over dx or f prime of x of a function f of x is defined as the limit as h approaches to 0 of f of x plus h minus f of x over h. So in simple terms, imagine that this is a point, another point, and this is another point, and h is the distance between them. So if you let f of x plus h goes nearer and nearer or approach f of x, or let h, or the distance between them, which is represented by h, goes to 0, then we will be able to get the slope between them, which is what derivative is. Derivative is all about the instantaneous slope of that function f of x. Okay, so if we will be able to evaluate f prime of x, then we will have the slope of the function f of x throughout its domain. Okay. So there are several rules for differentiation. So we have constant rule, the power rule, sum rule, product rule, quotient rule, and chain rule. So we are going to discuss this one by one. So let's start first with the constant rule. If c is a constant, the derivative with respect to x of c, or the ddx of c, is equal to 0. Well, it makes sense since c is just a straight line, right? C is just a straight line. The slope of a straight line, or the slope of any constant, is 0 since there is no change in height. There is no slope, or there is a 0 slope in all of its, or in its domain. Next is if c is a constant, or the constant rule, if c is a constant, the ddx of c of f of x is equal to c times the ddx of f of x. So, well, this just means that we can pull out constants from a term. Okay, so for example, we have a term ax to the fourth, and we are trying to differentiate it with respect to x. This means that it is equal to the, when it is equal to, as if it is equal when we pull out first the constant, that is the a times the ddx of the term x to the fourth. So next, the third rule, the power rule, the derivative, or the ddx of x raised to n is equal to n times x raised to n minus 1. Well, or simply the derivative of x of n, or x raised to n, is drop the n first, then subtract 1 to the exponent n. Or, so for example, x raised to 5, we will have, bring down the exponent first, 5 times x, then 5 minus 1. Or simply 5x to the fourth. So, rule is the sum rule. The sum rule, ddx of f plus g of x is equal to the ddx of f of x plus ddx of g of x. Or in simple terms, sum rule just says that we can break up derivatives like limits, or we can break up terms, or we can evaluate the derivatives of the derivatives term by term. For example, we wish to take the derivative of 2x cubed plus 3x. Okay, since using sum rule, we can say that it is equal to the derivative with respect to x of 2x cubed plus the derivative with respect to x of 3x. So using the constant rule, we can pull out constants. So it is equal to 2 times the derivative of x cubed plus 3 times the derivative of x. So 2 times the derivative of x cubed using the power rule previously is equal to, bring the exponent down times x raised to 3 minus 1 plus 3 times, bring down the exponent 1. There is 1 here since it is just a term, or it is just x. We can bring down 1, so we don't, 1 times x raised to 1 minus 1. So we will end up with the expression 6x squared plus 3. Since x raised to 0 is just 1, so this is the answer. So let's try to solve some examples. So find the first derivative of 3 times x raised to 5 plus 4 times x raised to 4 plus 7. Okay, using the sum rule, we can break it up into the ddx of 3 times x raised to 5 plus the ddx of 4 times x raised to 4 plus the ddx of 7. So using the power rule and the constant rule, we can pull out this constant and take the derivative of x raised to 5. So the derivative of x raised to 5 is equal to 5 times x raised to 4 using the power rule. Then the constant 3. Same with the ddx of 4 times x raised to 4. we can pull out first the constant and take the derivative of x raised to 4, which is 4x cubed, using the power rule. Then the derivative of a constant from the constant rule is 0. So simplifying, we will end up with the answer 15 times x raised to 4 plus 16x cubed. Let's solve another example. So find the first derivative of 3x raised to 4 minus x cubed minus 5x plus 1. So using the sum rule, we can break this up. So we take the derivative of 3x raised to 4 minus the derivative of x cubed minus the derivative of 5x plus the derivative of 1. So once again, we're going to use the power rule. So first we can pull out constants. Then take the derivative of x raised to 4, which is 4x cubed. That is 3 times 4 times x cubed. Then take the derivative of x cubed. We will have 3x squared. And the derivative of 5x, note that the exponent of x here is 1. Bring down 1, we have 1 times x raised to 1 minus 1, which is just x raised to 0 and 1. So the ddx of 5x is equal to 5, or negative 5 rather, plus 1, and will give us negative 4. Okay? This is wrong actually. This is 5. Then the final answer, upon simplifying, we will end up with 12x cubed minus 3x squared minus 5. So the next rule that we have is the product rule. So the product rule states that the ddx of two functions multiplied together is equal to the derivative of the first function times the second function plus the first function times the derivative of the second function. So let's try. For example, we wish to take the derivative of 2x plus 3 times x squared. Okay? So using the product rule, it is equal to the derivative of the first function, which is this. The derivative of 2x plus 3 using the power rule is 2 times the second function g of x times the second function, which is x squared, plus the first function, which is the 2x plus 3, right? 2x plus 3 times the derivative of the second function, which is the derivative of the x squared. Once again, using the power rule, that is 2x. Then simplify, and we will get the answer 2x squared plus 4x squared plus 6x, or simply 6x squared plus 6x. The next rule we have is the quotient rule. So the quotient rule states that if we wish to take the derivative of f divided by g, it is equal to the g of x times d dx of f of x minus f of x times d dx of g of x over the g of x quantity squared. Since this formula is a bit hard to remember, so let's say f is the upper function, since f divided by g is equal to f over g. Right? So since f is in the numerator, we can say that it is equal to the, let's let it be high, denoted by h, and g be low. So the formula, or the mnemonics of the formula, is equal to low derivative of high minus high derivative of low over low square. So, or low d high minus high d low over L square, or over low square. So that is the formula. Okay? Let's try some example. Example, we wish to take the derivative of x plus 1 over 2x squared. So using the formula, low d high minus high d low over low square, we can say that the derivative of this is equal to first low, which is 2x squared, times the derivative of the high, which is the derivative of this, which is just 1, minus high, which is x plus 1, over the derivative of the low, which is 4x, over the square of the low. So you can simplify this further, but I will just leave it like this. So next is the chain rule. The chain rule states that the d dx of f of g of x is equal to f prime of g of x times the g prime of x. So let's try with an example. Okay? So suppose we wish to take the derivative of 2x plus 1 raised to 9. Well, expanding it will do, or will solve the problem. However, it will be lengthy to do, and it is prone to mistakes and errors. So let's try to use the chain rule. The chain rule just states that, for me, I remember it as the derivative of the outside function times the derivative of the inside function. So let's first take the derivative of this and say, pretend that it is just like a random x. So what is the derivative of x raised to 9? That is 9 times x raised to 8. But we're not going to put x. We're going to put what this is, which is 2x plus 1 raised to 9 minus 1, which is 8. And then we take the derivative of 2x plus 1, which is just 2. So simplifying, we have 18 times 2x plus 1 raised to 8. Okay, let's try another example. So suppose we want the derivative of x, the quantity x squared plus 2x raised to 5. Well, first we're going to pretend that this is just a normal x. So the derivative of x raised to 5 is 5 times this, the thing that we pretend like x, which is x squared plus 2x, and it will be 4, since 5 minus 1 is 4, times the derivative of this, which is equal to 2x plus 2. And that's it. So let's try some examples, okay? So example, so find the first derivative of quantity 2x squared plus 5x plus 2 times the quantity 3x plus 1. So since this is a product, we are going to use the product rule. So the product rule states that it is f, the derivative of the product, or the derivative of f times g, is equal to f, or the derivative of f times g plus f times the derivative of g. So in this case, this is f, and this is g. So the derivative of this is equal to the derivative of f times g plus the derivative of plus f times the derivative of g. The derivative of this term is equal to 4x plus 5 times 3x plus 1 plus 2x squared plus 5x plus 2 times the derivative of 3x plus 1, which is 3. And then you simplify, and that's the answer. So that's 2 times 2x plus 5, right? 2 times 2x plus 5 times 3x plus 1 plus quantity 2x squared plus 5x plus 2 times 3. That is this term plus the derivative of this. That is this term times the derivative of 3x plus 1, which is 3. So simplifying, we have quantity 4x plus 5 times quantity 3x plus 1. This is plus 6x squared plus 15x plus 6. Simplifying further, we have 12x squared plus 19x plus 5 plus 6x squared plus 15x plus 6. And combining like terms, we will end up with 18x squared plus 34x plus 11. Next example, so we wish to find the first derivative of x plus 3 over 3x minus 5. Notice that this is a quotient, or in order to solve the first derivative of this, we are going to use the quotient rule. So quotient rule, using the mnemonics low d high minus high d low over low square. So it is equal to 3x minus 5, which is the low, times the derivative of the high. This is x plus 3, okay? Let me fix it first. That is x plus 3 minus the derivative, minus the high, which is x plus 3 times the derivative of the low over low quantity square, okay? So that we will end up with 3x minus 5 times the derivative of this, which is 1, minus x plus 3 times the derivative of this, which is 3, using the power rule. And 3x minus 5 quantity square, or the square of the low. So 3x minus 5 times 1 minus x minus 3 times 3 over 3x minus 5 quantity square. So simplifying, we will end up with 3x minus 5 minus 3x plus 9 over 3x minus 5 quantity square. And combining like terms, we will end up with the answer 4 over 3x minus 5 quantity square. So the last example, find the first derivative of the quantity 3x plus 4 raised to the 4. So notice that this is a function inside another function. In order to take the derivative of a function inside another function, we are going to use the chain rule. Okay? So using the chain rule, we first pretend that this term is just like an ordinary x. The derivative of x raised to the 4 is equal to 4x cubed. And then this x is that, okay? Substitute it back. We will have 4 times the quantity 3x plus 4 cubed. Then let's take the derivative of this term, which is the derivative of the ddx of 3x plus 4, which is just 3. And simplifying, we will end up with 12 times the quantity 3x plus 4 cubed. Then you can expand the given equation if required. And the exponential differentiation. So to take the ddx of a raised to x, we have a raised to x times ln of a. For example, we wish to take the derivative of 5 raised to x, that is equal to 5 raised to x ln of 5. So example, find the derivative of 4 raised to x. So using chain rule and the exponential differentiation rule, we have 4 raised to x times ln of 4 times d dx of x, which is just 1. So we will end up with the answer 4 raised to x times ln of 4. And find the first derivative of 3 raised to x squared minus 7. Notice that we have an exponent which is not an x. So we are going to use the exponential differentiation rule and the chain rule, since it is of the form of a function inside a function, which is, say, f of x is equal to 3 raised to x, and g of x is equal to x squared minus 7, and this here is f of g of x. So the derivative of 3 raised to x squared minus 7 is equal to 3 raised to x squared minus 7 times ln of 3 via the exponential differentiation rule times the derivative of the exponent, which is the d dx of x squared minus 7. Using the power rule, the derivative is just 2x. So simplifying, the answer is equal to 2x times the quantity of 3 raised to x squared minus 7 times ln of 3. That's all.